Hello, welcome back. So today we're going to talk about resonance in organic chemistry. So just to kind of start off getting our definitions down, resonance is a way of describing delocalized electrons within certain molecules. One Lewis structure would not be enough to describe this molecule because we have these delocalized electrons and it's not associated with a single atom. So we have to show this lone pair of electrons on all possible atoms. For example, we have NO3. NO3 has 24 valence electrons. Each oxygen has 6, so it'd be 3 times 6 is 18. Nitrogen has 5, that would be 23. And then because you know it's negative, you'd have one more for 24. So, starting off, we know we have nitrogen in the middle. And then we're going to have 3 oxygens. So we know nitrogen needs 4. It needs 8 in its octet, so we need a double bond on this oxygen. Just kind of filling everything out. Now it's negative here. We know this one has no charge because we got our 1, 2, 3, 4, 5, 6 on our oxygen. Nitrogen here, or 1, 2, 3, 4, 5, 6, 7, 8. You got 1, 2, 3, 4, 5, 6, 7. One too many. Oxygen 1, 2, 3, 4, 5, 6, 7. One too many. But we can also have our double bond there on our middle oxygen, or we can have it on the rightmost oxygen. So we see 1, 2, 3, 4, 5, 6. See, all these with the single bonds are negative. And one thing to note is that the charge has been conserved in all of them. Here we have 2 negative atoms, 2 negative atoms, and 2 negative. So those are 3 resonance structures, and we need to show them all to describe this. So now let's talk about when arrows. Let's have our curved arrows from tail to head show electron movement. So just a couple rules. One, we don't show single bonds as delocalized. Single bonds. So what I mean by that, say we have this atom, got a positive here, you want to move the electrons. Call it something like that, it kind of breaks, and then you have this being positive. This is a no-no. This would occur from a chemical reaction. Resonance is not that. Rule number 2, don't exceed the octet for second row elements. Boron, carbon, nitrogen, oxygen, fluorine. For example, carbon. Our H is here. We had this oxygen was negative. We don't want to be putting this lone pair here to create a double bond. Less than the octet is okay. Let's show that. Got our oxygen here, we got a carbon in the center. We want to move this double bond onto the oxygen. Draw head to tail. Now we have a carbocation in the middle. We got our 6 electrons on that oxygen. See, that would be negative now. And we see our charge is conserved. This on the left has no charge. And here the positive and the negative will still give you no total net charge. If you ever have a resonance where you have plus or minus 2, probably don't want to draw it. That's incorrect. So let's kind of show our contributing structures. So let's kind of show, got our carbon here. So let's just show some electron movement going on. So here we have our carbon with 3 bonds and a lone pair. See, here we have negative on this carbon. Well, we got to do something about that. Let's move these onto here. And let's show that our... So here we'd have to move something on this carbon. If we have a double carbon here, well then we'd have 1, 2, 3, 4, 5 bonds. So it would make sense that this double bond is moving on to that oxygen. So now we have a happy carbon here. It's got 4 bonds on it. And this carbon also has still 4 bonds. This oxygen is now negative. And we see that charge is conserved. So let's go over 2 more. Just I'm going to draw the contributing structure. See if we kind of understand. Got our structure here. It's negative. So I can show you what's moving. So we have this double bond moving on this oxygen. And a lone pair here creating a double bond. So what we end up with, hydrogen stays the same as oxygen, nothing's going on here. Then you have this carbon created a double bond again. You have this oxygen with only 2 lone pairs now. It says 1, 2, 3, 4, 5, 6. So that is neutral. This carbon goes to a single bond. And this oxygen has 3 lone pairs. And now this one will be negative. Do one more quick one, see that we got it. Got our hydrogen, oxygen, so what's moving here? Show this lone pair on the oxygen, creates a double bond with that nitrogen, and this double bond on this side turns into a lone pair. Get your hydrogen, your oxygen. Now there's only 2 valence electrons here. It's double bond with our N. With our oxygen on this side. It's got 1, 2, 3, 4, 5, 6. It's got 7 total. We see that that's negative. But we've still got one more thing. This left one has no charge. Right now, this one's negative. So we see this oxygen. It's 1, 2, 3, 4, 5. So that would be positive. You can note that it went from a neutral, turned into a double bond here, so you would get a positive. Alright, thank you.